Welcome viewers. I'm Mona Maheshwari, APEEE Department, RMD Engineering College. This session I'm going to discuss about full wave rectifier circuit. So this is your quadrant of operation of half wave rectifier circuit. The quadrant of operation is only first quadrant operation. That is, we are able to obtain V output positive and I output positive forward motoring mode of operation. Whereas if we require two quadrants of operation, we can go for full wave rectifier circuit. The quadrants of operation is first quadrant and fourth quadrant. The first quadrant is forward motoring mode of operation, and the fourth quadrant is regenerative braking mode of operation. So in forward motoring mode of operation, the voltage V output is positive and current I output is positive. That is in fourth quadrant, the mode of operation, regenerative braking mode of operation or inversion mode of operation, we are obtaining voltage negative and current is positive. So in full wave rectifier, it is able to operate both in positive and negative half cycles of the AC alternating current. Okay, so we are able to convert both positive and negative half cycles of the AC alternating current into direct, and the output voltage is double to that of the half wave rectifier circuit. So this is your quadrant of operation of single phase full wave rectifier. Now we'll move to the single phase full wave rectifier bridge converter circuit, where the load connected is RLE load. And in case of single phase full wave bridge rectifier, here you can see that there are four thyristors connected in the circuit. The two thyristors in the leg 1, thyristor name T1 and T4, and two thyristors in the leg 2, thyristor naming T3 and T2. The supply is connected, the phase terminal is connected to the A point, and the neutral terminal is connected to the B point. Okay, the A terminal is the first leg terminal between the devices T1 and T4, and B point is the terminal between the devices T3 and T2. Okay, this is your circuit diagram for single phase full wave rectifier converter circuit connected to RLE load. And the current assume the positive direction of current is I naught. The assumed positive direction of current is I naught is in this direction, and assumed positive polarity of output voltage is this plus here and minus here. So this is here assumed positive direction of current I naught. Okay, output current is represented by I naught, and the source current is represented by supply voltage and the source voltage IS. Now we'll move to the working operation. So we are assuming the continuous load current. So what is continuous load current? At no point of the omega t, the current is reaching zero. So this waveform is known as continuous current, output current. So it depends upon the L load considered, okay, in the load, and about the angle of instant of firing, the angle duration. So at no point the current is reaching zero. So such a current waveform is known as continuous current direction. Here we are discussing for continuous current mode for an RLE load connected. Okay, and here this is your voltage waveform VAB. Okay, VAB, this darker line represents the voltage waveform VAB. Okay, so when the VAB and the dotted line represents the inverse of it, the voltage waveform VBA. Whenever the thyristor T1 and T2 is conducting, we will be tracing the VAB waveform. Okay, whenever thyristor T3 and T4 are conducting, we will be tracing the voltage waveform VBA, which is nothing but minus of VAB, the opposite of VAB. So, okay, so this is your voltage waveform. Supply voltage waveform represented as Vs. Now, during the positive half cycle of the supply voltage, that is from instant 0 to pi, okay, the gating pulse is given to the thyristor T1 and T2. Okay, thyristor T1 and T2 are given with the gating pulse, whereas the rest two thyristors are in off state. T3 and T4 are in off state. So, with the gating pulse given to thyristor T1 and T2, how will be the current flow direction? So here you can see that from the source through the thyristor T1 through the load RLE load, through the thyristor T2 and to the negative of the supply. So this is the current flow direction, load current flow direction. The load current flow direction is same as that of the assumed load current I naught. So the load current is positive and the polarity of the output voltage is plus here minus here, which is same as that of the assumed polarity, positive polarity of the output voltage. So output voltage is positive. So when the thyristor T1 and T2 is conducting, the output current is positive and output voltage is positive, and the power is flowing from source to the load. So this is during the positive half cycle of the supply voltage, which means that phase positive and neutral negative. Now let us discuss what is happening during the negative half cycle of the supply voltage. Okay, so during the negative half cycle of the supply voltage, so what is happening? The trigger pulse is given to the thyristor T3 and T4 only at the instant pi plus alpha. This is your instant pi plus alpha. So until pi plus alpha, the thyristor T1 and T2 remains in conduction. This is because of the effect of inductance in the load. Okay, so here you can see that from instant alpha to pi, thyristor T1 and T2 is conducting and the thyristor T1 and T2 are in forward bias condition. Whereas at instant omega t equal to pi, thyristor T1 and T2 are reverse biased. Whereas the thyristor T3 and T4 are forward biased, but the trigger pulse is not given to these thyristors T3 and T4. And because of the inductive load, the polarity of the inductance is the polarity of the inductance, energy storage in the inductance makes it resistor T1 to ion on state is greater than the holding current value. So this makes it resistors to remain in on state. So until the instant pi plus alpha, where the next thyristors are triggered, the already conducting thyristors T1 and T2 are in on state. The waveform is tracing this alkaline waveform T3 and T4. Now we'll discuss the trigger pulse conduction from T3 and T4. Okay, the thyristor conduction from T3 and T4 from instant pi plus alpha. So this is your circuit diagram when T3 and T4 is conducting. The phase is negative and neutral is positive. How will be the current flow? From the positive through the thyristor T3 through the load RLE load through the thyristor T4 and to the negative, that is the phase terminal. The current is flowing this manner. So here you can see that the output current traced here is same as that of the assumed positive polarity I naught. So I naught is positive and the output voltage is same as that of the assumed positive polarity. So V naught is positive. So when T3 and T4 are conducting, the output voltage is positive and the output current is positive. Output current is positive. Okay, so here you are able to observe the output voltage waveform. Here we are tracing the waveform of VBA. This dotted line waveform we are tracing it. When T3 and T4 is conducting, we are tracing this dotted line waveform VBA, negative, okay, negative, which is equal to minus of VAB. And the load current waveform, here you can see that the load current, the inductor current increases, reaches a peak and then reduces to 0. So this is happening from instant pi plus alpha to 2 pi plus alpha until the next incoming thyristor T1 and T2 is triggered, which is happening at 2 pi plus alpha. Okay, thyristor T1 and T2 is triggered, and this is a source current waveform, and the voltage waveform, and this is their voltage across the thyristor T1 and T2. So you can observe this voltage across the thyristor. Whenever the thyristor is conducting, the voltage across it is zero. Whenever it is not conducting, the voltage across it is same as that of the applied voltage. So from instant 0 to alpha, thyristor T1, T2 are not conducting. So it is same as that of the applied voltage. We are obtaining this part of the waveform. And from instant alpha to 2 pi plus alpha, thyristor is conducting. T1, T2 is conducting. So the voltage across it is 0. And from instant pi plus alpha to 2 pi plus alpha, T1 and T2 are in off state. So it is tracing this darker line waveform. This is the applied voltage. VAB is the applied voltage for thyristor T1 and T2. So it is tracing this darker line supply voltage waveform. We are getting the wave shape like this. Whereas for discussion about the thyristor T3, T4, whenever it is not conducting, we will trace the dotted line waveform. Okay, VBA waveform is the waveform we will trace when the thyristor T3 and T4 are conducting. So the same way of discussion. From instant 0 to alpha, T3 and T4 are in off state. Sorry, T3 and T4 are in on state. So we are obtaining the voltage across the device is 0. And from instant alpha to pi plus alpha, T3 and T4 are in off state. So we are tracing this dotted line waveform. Okay. And from instant pi plus alpha to 2 pi plus alpha, thyristor T3 and T4 are in on state. So the output voltage, the voltage across the device T3 and T4 is 0. So this is about the circuit diagram and waveform for full wave rectifier circuit for alpha lesser than 90 degree. You can see that the firing angle alpha is lesser than 90 degree. So this is 0 degree and this is 180 degree and this is your 90 degree. The firing angle is less than 90 degree. It is rectification mode of operation, forward motoring mode of operation. We have discussed the first quadrant mode of operation. Whenever alpha is greater than 90 degree, we are obtaining the inversion mode of operation. The power is flowing from the load to the source. This mode is known as inversion mode of operation. And the output voltage, average output voltage for full wave rectifier bridges, V output is equal to 2 Vm by pi cos of alpha. And the average load current I naught is equal to V output is equal to 2 Vm by pi R cos of alpha. Thank you all.